Hi guys, welcome back. And today in our Selenium with Java video series, we are going to talk about inheritance of core Java concept. So you know that we have been talking about the core Java concept in Java for our Selenium with Java basic to advanced video series. And in this lecture with inheritance, we'll be covering even more features of the core Java. And you will see that we have covered quite a lot of details until our last lecture. So if you're not really watched it, I would highly recommend you to go ahead and watch there, because these concepts that we are going to be discussing in this particular lecture is going to be something that is going to be completely inherited from our previous session. So the inheritance is already inheriting some of the course functionality from our last lecture. So please go ahead and watch there so that you can have a solid understanding of what we are going to be discussing in this particular lecture. Well, as I said, let's get started with the inheritance. So what is this inheritance? Well, inheritance is yet another OOPS principle, like the encapsulation that we saw in our last lecture while we were discussing about nested classes and how the nested class encapsulates the functionality in a single group within the same class, so that you can just call the class in the caller class and it's just gonna perform the operation that you're looking for. So that's the encapsulation. And over here on the inheritance is one more object-oriented programming concept, which is going to be very, very helpful for you while you work with multiple different classes. And especially if you're going to be working with a class which has to inherit or use some of the functionalities from the existing classes, you can just use inheritance, and those things are going to be done for you automatically using this inheritance. So I highly recommend you to watch this particular lecture, because this video is going to be very, very helpful for you to understand the inheritance concept very clearly. Well, as I said, inheritance allows us to inherit not only the functionalities of a class by using its method, you can also inherit the field which is also available in the base class. So when I say base class, the class which you are extending from is called as the base class, and the class which is extending it is called as the subclass. So now you will see that I'll be calling like a base class and a subclass. You remember in our nested classes while we were discussing, we called this like an outer class and inner classes. And over here, we are going to call them as the superclass and or the base class and the subclass. So we will use like base class or superclass interchangeably, and that's how things are going to be in the programming world. Well, as I said, you will notice that the inheritance structure is going to look something like this. You'll see that we're going to have something like a superclass, and then we will have a subclass, and it can have any number of subclass. So a subclass can extend a superclass, and the same superclass can be extended by multiple different subclass. And this superclass can also extend from another superclass. It doesn't matter how many extensions or inheritance going to keep on happening. So those things are going to remain exactly the same. The hierarchy can keep on extending from the top to bottom, however that you want it to. That's how the inheritance really works. So you can see that the subclass can extend the superclass by inheriting all the public methods and fields of a superclass. And by this way, you will notice that the inheritance concept is going to make things more easier, because you can put some of the most common functionality between these two subclasses into a superclass, and you can then extend the functionality in both the classes. So that way you can see that you can reduce the number of lines of code that you're writing in the subclasses, and you can move them all to the superclass. So that is another way that you can reduce the number of lines of code, and you can write a neat code. For example, the superclass or a base class can be like a an class which is going to be reusable across both the classes. And one of the example in Selenium is, for instance, if you're going to be writing a like an iWeb driver code, and it is going to be used by both the Chrome driver as well as the Firefox driver, then you can just write or just consume the functionalities from the superclass. If there is any common functionalities in the superclass, you can just consume that by extending the superclass or the iWeb or the web driver class in the subclass, and then you can just write your own functionalities in the subclass as well if you wanted to. So subclass can extend the superclass methods, and it can also have certain methods specifically for these classes. For instance, a Chrome browser can have some functionalities which the Firefox browser will not have, right? So in that case, even though you extend from the WebDriver superclass, you may have certain functionalities specific to Chrome and specific to Firefox. So those things are going to remain over here. And there is also something called as interface concept, which I have not really talked so far, which we'll be talking about pretty soon. And in that interfaces, you will notice that it is going to make things even more simpler in terms of contract, which is it establishes between classes by implementing an interface. Well, those things we are going to be talking about later, but at least on the superclass to subclass level for the inheritance, you will notice that every single time, just think about this, every single time while you have classes, and if those classes are going to share specific functionality, you can put those functionality as a superclass, and then you can extend the superclass into your subclasses. And the good thing is the subclasses can also have their own classes, which you can just use it. But not only that, a subclass can also override the methods or functionalities of a superclass specific to this class, which is going to make things even more easier, right? For instance, if a superclass for a WebDriver in the Selenium, which is going to direct like close functionality, like closing the browser functionality. What if the closing the browser functionality is very specific to Chrome browser and the Edge Chrome browser and Safari browser, but not for the Gecko driver, which is the Firefox browser? So then the Firefox team will have to maintain the close method of the WebDriver very much same as other browser drivers, but still they wanted to perform the close operation even though it doesn't work. So what they have to do is they will override the method. So that's how the overriding concept really works. So I hope you got the idea how that works. I will show you an example so you get it. It makes more sense that whatever that functionality that we're talking about, it is all going to be written in the code, and you will see it in even more better fashion. Well, as that said, let's jump in our code and I will start writing the code over here so that you can get better idea. So for doing that, I'm going to create a new package this time, not with the existing code. And over here, I'm going to call this as Selenium mock driver. That is the package. And over here, I'm going to add a new class and I'm going to call this as WebDriver. See, just pretty much exactly like how Selenium does, but it's really not the actual WebDriver, to be honest. This guy is now going to be like a base class or a superclass, for instance, right? And you know that Selenium browsers, what it does is like it opens the browser, and then it close the browser. And the meantime, it also does a certain navigation of the URL and some more functionalities. I'm just going to leave this for now, right? And then I'm going to create two more subclasses in the same package. I'm going to call this as the Chrome driver. So C will be in capital letter. And then I'm going to create one more class and I'm going to call that as Firefox driver. So these are the two classes that I have got. Now what I'm going to do is in the WebDriver, I'm going to implement certain functionalities which the Chrome as well as the Firefox team are going to use, because the WebDriver definitions are maintained by W3C, which is the World Wide Web Consortium. So they are the one who actually do the driver specification these days in Selenium. While they write the code, or they just do the specification, but I'm just trying to hype up the thing even further as if like they are writing the code while they don't. So I'm just going to say like, okay, these are the functionalities which a browser should and must implement. One is the open browser, right? So I'm going to say public void open browser. So I'm going to say open method, right? And then I'm going to say system.out.println of opening the browser. And here I'm going to get the browser name, for instance. So I'm going to say browser name. And I'm going to print that value over here, just that I want to show you from which browser it is going to be getting that output from. And then I'm actually going to create one more method, which is going to be for the navigation. So I'm going to say URL, and say navigate. And this method, so you know that in Java, we have to use the method name as small letter. That is the convention that is used across. So I'm going to keep the convention over here. And I'm going to say navigating to URL. And I'm just going to say URL. And I'm going to create one more method over here. So even though we have not discussed about methods so far in this entire series, we are writing quite a lot of methods. Unfortunately, I'm very sorry I have not really talked about it. The next session, I promise you, we are going to talk about methods and method overloading and other stuff. But at least just bear with me. This is how the method is written, and you are already familiar with methods so far that we have been writing. So hopefully you know what we're going to be talking about in the next lecture as well. And then I'm going to close the browser, and then I'm going to say browser name. So probably I'm just going to copy this whole thing. And I'm going to paste it over here. I'm going to say closing the browser. Cool. So these are the method that the superclass or the WebDriver class is going to be writing. Now what I'm going to do it is in the Chrome driver, I'm going to perform certain functionality which are very specific to Chrome driver. So I'm going to say Chrome driver specific functionality. So what are these functionality here? It is going to be opening the browser, navigating to the URL, and then closing the browser. And it's going to be the exact same thing for the Firefox as well. It is going to have some Firefox driver specific functionality. Along with that, it is going to have opening the browser, navigating to URL, and closing the browser. While these manufacturers, like companies, which is going to do the creation of the drivers, they see that, oh, there we go. We have a very generic functionality which has been implemented by WebDriver. So why can't we just extend the functionality directly? So what they do, like these companies, the Chrome as well as the Firefox companies, Chrome is maintained by Google and Firefox is maintained by Mozilla. So what these company does is like they just go and see what functionalities that they can extend from the WebDriver. So they see that opening and navigating and closing browser, they all are pretty much exactly what they're looking for. So they just go here and they will just do what is called as inherit from the parent class, which is nothing but the WebDriver class. So in order to do the extension of the class or inheriting the class from a superclass, and this is the subclass right now, the Chrome driver, where it is going to extend from the superclass. And in order to extend from this subclass from a base class, we use a special keyword called as extends. So this is the keyword. You see that now it's in purple color, which means it is extends. It's a keyword or a reserved keyword which has been used within Java. Now over here, I'm going to say extends from WebDriver, something like that. So now what I have did is now I have extended the functionality from the WebDriver in this Chrome driver class, which is cool, right? So if I just save this, I'm not going to do anything apart from this one. I'm going to go to the first program.java over here and I'll comment this this code. And you remember how to do the commenting. You just have to go to the source, add the block comment or toggle comment, whatever that you like it. You can just do that, which is going to be this one. This time I'm just going to use the block comment. You see that? That's how I comment the code. And now what I'm going to show you is that a beauty here is that if I'm going to create a instance for the Chrome driver, like that, is equal to new of the Chrome driver. And you notice that I have not written even a single line of code on this class file, right? So this entire class is right now without any single implementation of any method as such. But now if I try to create an object like Chrome driver is equal to new Chrome driver, it also shows me a screwy line over here saying that it couldn't able to import. See, there is a cross symbol because this is for the first time we are accessing a class from a different package. You see that this is a different package, Selenium mock driver. So what we have to do while we access a class from a different package in another package, then we do what is called as import, and you just put control space over here. See that we get the Selenium mock driver. So this is what we do, the importing all the classes from that package, not only all the classes but also all the types. It could be an interface or it could be an enum. If you want to import everything, you need to use this import keyword from the Selenium mock driver. Dot means the directory, following that import everything. This is the asterisk refers to. That is how I do an importing of all the classes from Selenium mock driver package into my basic day one package. So this is cool. We really not discussed about this one so far, and it's a good chance that we could able to discuss this as well, which is cool. So hopefully you got the idea. See now that there is no scrolly line over here, which means I could able to import this. So now if I try to comment this line of code, what's going to happen? The ID is going to complain me saying that it couldn't able to import, but the ID also gives me a quick fix saying that the Chrome driver is available in the Selenium mock driver. So if I go and hit that, it's gonna add the exact same thing for me over here, but it just also add the specific class like Chrome driver. But if I want to import everything like a Chrome driver, Firefox driver, and web driver, like everything together, then I can just use the asterisk over here, which means it's gonna still work as expected, but just that, yeah, that's how it works. So I hope you got the idea of like how we do the importing of the package in Java. So now that I have a Chrome driver, and as I told you, from the Chrome driver, we don't have any single line of implementation of the methods yet. And if I just go to the first program, and if I try to put a dot, you remember not to access a method, we always use the dot after the object name. And if I do that, you'll notice that I also get the method for opening the browser, closing the browser, navigating to the browser. And do you know why all these methods are coming? Because we did the extends over here to the web driver. So if I remove this extends right now, I save this, and if I go back, and now if I go and put a dot here, I will not get the open, close, or navigate method. That's inheritance, guys. That is how we do the inheritance. The extends keyword does all the magics of doing the inheritance from the base class or the parent class or super class in this fashion. So now that we got the idea like how we actually do that. So if I just go to open, and then if I just put a browser name, which is going to be Chrome over here, and now if I try to run this code, you will see that it is going to show me opening the browser Chrome for me. So if I do the exact same thing for Firefox, if I do an extension, for instance, if I just go to the Firefox, and if I just say extends web driver, and if I just go to the first program, and now if I create an object for Firefox driver, and now if I just call the object Firefox driver dot, you will notice that I'm going to get all the methods as well, because this has extended the exact same thing. So if I just say open, and I can just say Firefox like that, And if I try to run this code, you should see opening the browser Chrome and Firefox. So it creates, because since we have created two objects, they won't collide with each other. They will have their own copy of the object, which is Firefox driver and Chrome driver, and they can keep on extending the method as they wanted. And that is powerful. This is how we do the inheritance. And now let's take a step further. So what we're going to do right now is the Google Chrome guys are like, okay, we also need to implement some Chrome specific functionalities, which are very, very specific to Chrome itself. So they can implement methods by their own. They can have public void, let's say I'm going to have a reader view functionality, which is very specific to Chrome. And then I'm going to say system.out.println, and I'm going to say Chrome page reader functionality. And what happens right now is once you have a method on the Chrome driver, even though they both are, the Chrome driver as well as the Firefox driver, both are related with each other in terms of the web drivers at least, you can't access the method specific to Chrome itself. So you can't just say Firefox driver dot, and then you cannot say the reader mode or something like that. You can't get that. It won't work that way. It is very specific to Chrome driver. So only Chrome driver dot, and then if you say reader view, it's going to be available for the Chrome driver, right? It's not going to be available for a Firefox driver. So you can have very specific method for Chrome driver. And that's going to be exactly the same for Firefox as well. So I'm not going to write any method over here. But what if the navigation functionality of Firefox is a bit different from Chrome driver? So the functionality which the WebDriver team has implemented is going to be not working for Firefox, because Firefox uses Gecko driver as opposed to the Chrome driver. So it is entirely different. So what if this Firefox team needs to implement their method for navigating, even by keeping the same naming that they have used in the web driver itself, like navigate functionality? How do they actually do that? Well, not to do that, we can do the same method name and the signature in the Firefox driver, which is just go to the web driver and we just copy this navigate method. And if you just go to Firefox driver, you can paste it over here. The moment I do that, you see that the IDE actually shows me a triangle over here. It says that overrides the Selenium mock driver.webdriver.navigate method. You see that the IDE is very intelligent enough to tell us that this method name and the signature exactly matches to the superclass. So I'm sure that you're trying to override it. And now if I just say navigates, for example, this arrow will go away, which means it is not really overriding. So if the method has got the same name and the same parameters count and the signature, you can still you're essentially in a business of overriding. But what if you have a same method name? I'm just gonna comment this code and I'm gonna put an integer here, for instance. It is not essentially overriding. See, because the data type of this parameter of this method is different from what you have in the WebDriver superclass. So it always expects to have a string. So if you don't have a method with a signature of string, rather if your subclasses are trying to implement using integer, then you are not essentially overriding it. So that is what it really means. So you should always maintain the type, the signature. That's why I always say signature on the same types. So hopefully you got the idea like how this all happens. So in order to uncomment this particular code, I can just do something like this. So now you can see that I have fully uncommented it. And now if I try to override the method, all I'm going to do it is I can do something like this, or I can also use a annotation here as override, like that. So this is something, it tells you explicitly that tomorrow if somebody is going to read your line of code, like your classes, you're essentially telling that, okay, you're overriding the superclass. That's what you're essentially doing. So that is an annotation in Java which does that for you. So that is called as annotation. So if you use anything like a hair symbol or at symbol, which is used very specific for Java over here, so that's how you can do it. You can't just write something else, because override is something which is very specifically available in Java language for you to do that. So you can override it. Now this is like, the code is also very, very readable over here. So over here, you're going to say you have overridden the navigate to the URL. And what I'm going to do is navigating to URL for Firefox specific browsers. Hope you got the idea. Now I have modified the functionality, the printing functionality a bit. And now if I just go back over here, let's say if I go to the first program, and if I wanted to see what's really happening with the navigate functionality, like that, and I'm gonna say Firefox, and now guess what is gonna happen when I try to run this code? You will notice that I'm gonna get a different output altogether. See that? Navigating to URL for Firefox specific browsers. And if I do the Chrome driver dot navigate, and then if I just say Chrome, the output is going to be different, because it is actually using the navigate functionality from the WebDriver class, which is a super class. Whereas this guy, the Firefox, is really essentially overriding it in its own class. That's why it is called as the overriding functionality. That's why it's printing in a different way. So hope you got the idea. And there can be even more functionalities you can do. I'll tell you one more thing just before we close this session, is we can use the navigate method. Let's say you have to use some functionalities from the parent class, and also you need to do the extension within the same method. How do you actually do that? Well, in order to do that, you can use a keyword called a super dot, and then you can call the navigate over here. This is super is one more time. It's a reserved thingy. And over here, I'm just gonna say an URL like http / google.com or whatever. So if I do this one, what it does essentially is that it is also gonna call the navigate method from the WebDriver class. And also it has their own implementation in the Firefox browser. It could happen, right? You can use certain functionalities specific to your browser, but also keeping the existing features which is provided or offered by the existing classes to be available for you as well. You can do that. That's the super keyword for you to do it. And once you do that, let's try to run this code. See, the output is going to be a bit different this time. You're going to have opening the browser Firefox, and also it says navigating to the URL, just go to google.com, and then navigating to this URL specific for Firefox browser. So you get a good thing of both the world. So that is how you do the inheritance in Java, while you do quite a lot of things over here. So hope you got the idea of how you actually do things in Java with inheritance. And inheritance is one of the most powerful concept, and this is very, very useful while we write the automation testing code with Selenium Java. So please make sure that you get this idea very clearly. If not, please go ahead and try to relearn what you have watched so far from this point to the beginning of this video. Just keep on re-watching it, and then try it yourself, because while you watch these videos, sometimes it feels like it is straightforward, but while you try writing the code by yourself, you get into a situation where things may be different. So I would highly recommend you to try out yourself so that you will know how to work with inheritance in Java. So catch you in the next one, the method concept, because I promised you that we are going to be talking about methods in our next lecture. Catch you in the next one. Thank you.